Hello and welcome to the 11th Houdini Kitchen tutorial. For this one we're going to go back to basics and look at lines and curves. If you're working on procedural geometry, say for a video game, there'll be a lot of situations where you need to actually build this geometry yourself, and curves is a good way to do it. So it's worth understanding exactly what you can do with them, which is very powerful. Also, if you're working in Unreal, you will know that there's a curve tool within Unreal which you can hook into your digital assets. So if you set up a digital asset that has a curve as an input in Houdini, then you can actually access this curve inside Unreal, which gives you a lot more control over how you would place objects. First of all, I want to talk about how curves actually work in Houdini and the difference between curves and edges. So I'm going to drop down a grid object. Something that you may already know about Houdini is that Houdini doesn't explicitly have edges as a component. So if you're used to working in another 3D program, you would probably be familiar with the idea that you can build your geometry from vertices, polygons and edges. However, in Houdini, an edge is simply the edge of a polygon, and it's an integral part of the polygon, which they call primitives. So it's probably easiest to demonstrate. Let's drop this down so that we've just got a split down the middle. Now if we look at our geometry spreadsheet, you'll see we've got our points with our point numbers, and then we've got our vertices, which are our points per face. Then we've got our primitives, and in this case we have two primitives. So there's one and here's two. And then we have our detail, which is simply attributes attached to the whole object. So you'll see there's no edges here. If we take a look at our vertices, we can see how our polygons are constructed. So the first one, so that's 0, is 0, 1, 3, 2. So if we look at this, we've got 0, 1, 3, 2. So we have a clockwise face here. And then the second one is 2, 3, 5, 4. So we have 2, 3, 5, 4. Now what we do have in Houdini are something called half edges, which I'm not going to go into much now because they're really just accessed through VEX code, but once we get into that you'll find that they can be really powerful. A half edge is basically the line that runs between two vertices rather than 2 points. So each of these is a half edge, but this line down the middle is actually two. So there's one that goes this direction, which is part of this polygon, and one that goes this direction, which is part of this polygon. However, what we're looking at today are curves and lines, which are something very different. And a curve and a line in Houdini is basically a primitive, so it's treated in exactly the same way as a face. So let's try reducing this down to a single polygon. So we have one polygon here, and I'll show you a way that you can see more clearly a line. So if we use a node called end, this has some tools that we can use to play around with our lines or curves. So the u, when we're looking at a curve, is basically the distance along the curve between 0 and 1. So starting here would be 0, this would be 0.25, 0.5, 0.75, and then up to here would be 1. If we open it, you see we've no longer joining these two ends, and now it looks like a curve. So in Houdini, a polygon is simply a closed curve which skins a surface across it. There's also a concept in Houdini of unroll. There's two ways to do this. So unroll takes a full primitive but doesn't skin the surface. So now we have a curve, and this curve is actually open because there are actually 2 points here. There's a 0 and a 4 which touch each other but they're not joined. We can also unroll with shared points, in which case it's a closed curve. Now if we go back to the geometry spreadsheet, you can see we have a single primitive, and you can see the same thing if you middle mouse click. We have one polygon, which you might not expect, because although it's not skinned, it's still viewed as a polygon, and it consists of one primitive, 4 points and 5 vertices. At this point, you could argue that you've actually seen curves in Houdini, and in fact there are several tools that allow you to, you've seen edges. There are several tools that allow you to manipulate edges in Houdini as if they exist. However, these are more complicated tools that behave as if edges existed, whereas in fact they don't. And the concept of edges don't persist through all the Houdini nodes, so it's not terribly sensible to work with them unless you're doing something quite sensible. One place you'll see them is in the group node. So you can see we have an option to select edges, which gives us exactly what we would expect. Let's split this up again and select a subset. So let's grab bounding region. Okay, so now we've selected a subset of edges, and if we stick in a glass node, once again we've got the option to select edges if we want, and delete non-selected. Now we're not getting what we would expect. You'd expect just to see the edges and nothing else, but because the edges don't exist on their own in Houdini, we can't actually do that. If you did want to take this group of edges and get something a bit more like you'd expect, let's make them an incomplete group. So I'll move this across. Right, so now we've got something you would expect just to sit on its own if you were to remove everything else. So if we go to the dissolve node, the dissolve node is similar to the blast node, but it tends to be used on faces. If we go to delete non-selected and stick in our group. Oops, I don't have the group selected there. Here we go. Okay, so here your group, although it's only 3 edges, you're still getting the full polygon. Now if we go to the dissolve node, we're not seeing anything. But if we go to create curves when dissolving boundary, that will recreate our edges as curves. So what we're doing here is we're taking the edge group and we're turning it into a curve made of primitives. So if we open this up, we'll see once again we've got one primitive. So this is taking the edges, which are an imaginary concept in Houdini, and turning them into a curve, which is a real existing object in Houdini, and now we can work with that. So now I'll show you some of the basic tools for creating curves. So the most basic curve tool is a node called line, which simply creates a straight line. Here we go. So you give it an origin and a direction. So let's change the direction. And you can give it a length and give it a however many points you want. You can create this as a polygon, which, as we said earlier, will create a single primitive and a collection of points. Or you can create a NURBS curve, and a NURBS curve in a straight line is going to behave in pretty much the same way as a polygon. Or we can create a Bezier curve. We'll go into both of those in more detail once we look at a curved curve, because then you start seeing the differences between them. You can also just create a collection of points. Because this is super simple, it's useful for creating procedural geometry, so we can hook these up to other things, and I'll show you an example of this a bit later on in the tutorial. The node you're most likely to use to create curves and lines is called a curve. So this has a lot more properties, and the way that we create it is, you could type in a list of coordinates here, but generally you create them in your view space. So if we hit enter, we can now add a group of points and just draw a curve. It creates them parallel to the viewport, so if you want to create them on the grid, you would switch to one of the predefined viewports. But this will do us for now. So you can see this has automatically created a group of coordinates. The x, y and z are separated by commas, and then there's a space, and then the next coordinate. At the moment we're just creating a straightforward polygon, and these settings don't have a lot of relevance. However, once we start looking at NURBS, then these make a difference. So if we use a CV creation method, these are called control vertices, and what they do is they're used to influence the placement of the curve rather than being points directly on the curve. So let's remove these points and start again. So you can see that the curve doesn't go directly through the points, they're just used to influence its position. There we go. So a control click onto the first point will join it up and turn it into a complete surface. Once you've created the points, you can go back and move them around. This still works within the individual node, so as long as you're just working on one point, it won't create any edit nodes, so you can get exactly what you want. Next method to create is using breakpoints, and you see in this case it actually tries to fit the curve through the points. So we're getting a slightly different shape. It's just a different way of working. The breakpoints will give us something a bit closer to our original polygon shape. The Bezier curve works in a slightly different way. So let me start again, it'll be easier to understand. Let's go for CVs. So do it in the top down view this time. So for a Bezier curve, we have groups of 4 points. So this is determined by the order here. So if we change that, we can have smaller groups of points. And we have, it's probably easiest to think of a graph, which is where you might normally come across them. So we have our end point, and then we have an influence point. And then at the other end, we have an end point and an influence point. So if we click enter, you can see now the curve passes through our end point, and we can use the influence point to determine the direction that it comes out of that point. If we create a curve that has more than 4 points, it just starts again. So we have our 4 points, and now we have another 4 points. In fact, it's another 3 points because the third point acts as the start of the next curve. So if we click a group of curves, you can see we have our curves that sit on the line, and then we have the input and output curves that influence them. It's probably not something you would use that often, but it's good to understand how these work. You can also change the order. So if we have an order of 3, you see every second point sits on the line, and then both of these are influenced by the point in between. If we switch now to breakpoints, you can see it's trying to put the line through every single one of these points, and we get something a bit odd. Stick it back to an order of 4 and go back to NURBS and CVs. Now, it's also possible to use input geometry as a reference. So let's say put in a sphere, and we'll make it a polygon. So we'll drag this to the input. If we switch on keep input geometry, we can see it here. Now, instead of putting our coordinates in, we can now reference any of the points in our input geometry. So if we, where's our start point? So we're starting here. So the nearest point is 19. So let's change this to P19. So this references the 19th point on our sphere. So you can see you could use this to use an underlying object to influence the positions of your curve, which could be one way of making it a bit more procedural. The last way to create a curve is to create it freehand. So if you make it freehand, then you're simply drawing a collection of points, and the curve will do its best to fill in the gaps. So you'll see this creates a large number of points. Once you've created your freehand curve, you can play around with the fitting properties. So you can change your tolerance, so it will be a little bit less precise about how it fits them. So you can see the CVs here are greatly reduced once you start playing around with the tolerance, and you can play around with the smoothness as well to get rid of the sharp edges. In most software programs, you'll tend to either work using NURBS or polygons, and if you're working in games, you probably mostly use polygons. However, in Houdini, it's very easy to switch backwards and forwards between them. So if you want the properties of a NURBS curve, then you can simply convert to a NURBS curve, play around with that for a bit, and then convert it back to a polygon. And there are various ways of doing these conversions. I mean, as you can see, we can simply create the right kind of curve to start with. but we can also use a convert node. So this is by default converting our NURBS to a polygon, and we can play around with things like the number of divisions. It's a good way of smoothing out your curves or reducing your geometry. We have a related node called a draw curve, which, if you're creating procedural geometry, it's probably not something you're going to use very often. It's a very unprocedural way of working, but it's quite nice because it can be used to project onto an object and keep that relationship live. So if we stick a sphere in again, oops. And if we hook it up to the first input, I need to change here our projection object to the input geometry, and now we can paint strokes directly onto our object. And if we use rays or UVs to connect to our object, then we can move the original object and the curve will update with it. One last way that we're going to look at in this tutorial for creating curves is using the add node. The add node you can use to individually place some points. So if we switch this on, we have a point at 0, 0, 0, and let's add another one. So here we're just creating individual points, but we can also use it to make lines. And the reason this is quite nice and quite procedural is because you can pick lines out of another object. So let's create a grid and hook this up. So if we go to polygons, so we have an input polygon here. I'll get rid of our points. And now we can, so we're selecting here by pattern, we can give it a list of the input polygons. This is actually really similar to using the PN syntax in a curve. So we can give it, say, 64, 65, 66, and we now have a line that goes between those 3 points. Let's turn a corner here. But a more intuitive way of doing it is we can add a group. So if we stick a group in here and select some points, oops, oh, points rather than primitives. So now we have a group that consists of these points. Then we can add our points by group and select that group. So we've got a line. That, it's quite an interesting shape here because it's doing the points in order. Because grouping can be procedural as well, this gives us a bit more procedural control over the way we create our curves. So now that we've got our curves, I thought I'd show you some ways that you might use them in a scene of procedural geometry. So we're going to imagine we're creating a racing game and we want to lay out a track. and tracks are something that use a lot of curves. This will also introduce us to some of the ways we can manipulate our curves to create geometry, though we'll be going into each of them in more detail in further tutorials. So I'm going to come out of here and create a new object. Make a new geometry node, and I'm going to create a grid and then a mountain to give us a landscape, which will be our gameplay map. Let's make this high resolution. Let's make something a bit smoother and a bit simpler. Yeah, let's give ourselves a reasonably smooth and straightforward terrain in which to build our track. That'll do for now. So we'll make this procedural so we can change the terrain later. And now we want to create a curve that can sit on the track. I know I've shown you just a minute ago how to draw curves directly onto a surface, but in this case, instead of just the curve of the direction of the track sitting on the surface, we want the entire track to sit on the surface. So we're going to create it above the surface and then project it down onto it. So to start with, we're just going to create a curve above. So we'll go into a top-down view. And we'll go into the curve tool. And at this point, let's create an NURBS curve. And use Control-click to close it. Although we're not looking for a surface, we do want our curve to be closed because we want our track to be continuous. If we go back to our perspective view, we want to transform this so that it sits well above the track, because we're going to use a ray tool to project it back down onto the surface. We'll lift this up, and then if you remember, we used an ends tool to unroll our curve, which means we no longer have the surface sitting inside it, and we want to unroll it with shared points because we want it to be continuous. I'll stick the points on so we can see what we're doing. Now we have the path that our track will follow. Now we want to do the cross section of the path of the track. So for this, we're just going to use the simple line tool. So we're going to give it a direction along X, and we'll give it a few points. So let's make that. Five points, there we go. So if you imagine this being a cross-section of the road, we have the left and right points are the edges of the road, and then we have one in the middle which we can use to make a centre line. We want to make this vaguely procedural because we might want to change the scale. So I'm going to offset it so that our centre point sits at the origin, and this is what will be attached to our curve. So if we the length and paste a relative reference in here, and then multiply it by -0.5. This will move us back by half the length. So now you can see you can change the length and it always stays centered in that middle point. And now we use a node called sweep, which has very similar counterparts in lots of modeling programs. So it should be quite straightforward. Here you input the cross-section curve, and here you input a backbone curve. So now you can see at the position of all the CVs on our curve, it's placed our cross-section, and it's done quite a nice job of rotating it in the same direction as the curve. We're not getting very many points here, so I'm going to use something called a resample node, which is an incredibly useful node when you're dealing with curves. It allows you to rebuild the points without changing the curve, and you've got lots of control over them. So for example, here you can change the distance between them. You could also give it an overall number of segments, if that's an easier way to work. And you can use a combination of both to just take a section of your curve. So we want to be able to change the frequency so we can create more backbone curves. You see here we're getting a bit of crossover in the corner, so we'll make our length a bit smaller. And then go back to our sweep, and we want our output to skin with autoclosure. So this will create a surface for our road. So the next thing we want to do is project our road down onto the surface underneath. And for this we're going to use a fantastic node called array node, which will do loads of things and will have its own tutorial later. For now we're going to use it in the most simple way. Basically what array node does is projects rays from one object to another and sees where they intersect, and then you can, if you choose to, move your first object onto those intersection points, which is what we want to do here. For this we need our mountain. So first of all we have our points and primitives that we're going to move. So this is our road, and then we have our collision primitives, which will be the mountain. We need to tweak the settings a bit. So by default the direction that we're projecting is the normal direction, which is actually up. We always want to project down onto the surface, so we'll change that to a vector. Reset our vector and make it -1 in y, and now you can see our road has snapped down onto the surface of the mountain. And this will update as the mountain changes, so you can see you can tweak it and the road will always stay sitting on the surface. Oops. I'm going to add a little bit of colour so it makes it a bit clearer what's going on. So I'll make the road colour, and we'll make the mountain green. We're not actually seeing the mountain here, it's only visible so that we can check that our placement working properly. What we actually want to do is merge it with the original mountain, so we use a merge node as well. Because our surface is projected exactly onto the surface below, we're getting some intersections, and we can actually fix that inside the ray node. So there's an option to lift. Because we're projecting in -1, lifting it will actually take it below the surface, so we want to go into the negative numbers, and that will pull it just a little bit up above the surface. So you can see now you're getting something that's starting to look like a racing track. And the nice thing about this is we can go back to our curve. If you remember, it was possible to edit our points while the curve, after the curve had been created. So we can start playing about with our CVs. Let's turn points off so we can see them a bit more clearly. So now we can change the shape of the track interactively, and it will stay sitting on the surface. If we pull these out a little bit, we should be able to make the track slightly wider as well if we have corners that are not quite as steep. So again, this is all procedural. So next thing we want is some white lines down the middle of our road. And in order to do this, we're going to create a new curve that sits exactly on the surface of the road. And we'll use the add tool to grab some points from our road surface. First of all, we need to set up a nice procedural way of grouping all the points that run down the middle of the road. And for this, we can go back to our original line. So if we take a look at this and switch points on, you can see, if I can find it. There we go. So you can see our original line consists of 5 points, and we want the middle one. Because we've offset it by half its length, the middle point will always sit exactly at the origin. So we can use a group node, and we can use an expression to select the point that sits at 0, 0, 0. So we have p equals 0, 0, 0. And if we middle mouse on that, oops, that's a primitive group stuff, we want a point group. So you can see we now have a point group which has one member. It's worth checking because it's quite hard to see if there's a selected point underneath all the icons here. We'll call this group middle. Now the nice thing about this is that as we sweep our line around our curve, it takes all the points that are created by that middle point and keeps assigning to that point group middle. So you can see here we have a point group called middle with 111 points in it. So this represents all the points that run down the middle of the road. And it is, because it's part of this surface, it's projected down onto the ground along with this group. So we can take it out from the ray and we can use our add node. So the add has an input of this geometry. If we go to polygons and by group, we can select the middle group, and you'll see we've now got a line down the middle of the road. Because we're adding it, we're also including the road as well. So we want to go back to points and delete the original geometry. So in this case, we just want the line that runs down the road. In order to get our, so we'll merge it in here. In order to get our white lines, we can use the sweep node again. So first of all, I'm going to create a grid because we just want a square polygon, and I'll just give it 2 rows and columns, and we want it to be very small. Let's make it 0.1, not 0.1 for now. We can tweak it once we've got it sitting on the road. And then we use another sweep node. And once again, we put our backbone in. So for the backbone, we want a new curve that we created. And for our cross section, we want a grid. So here you can see we now have our white lines. And now we can go back to the grid and play around with getting them the right size and shape. We probably want them a bit smaller than that. So after the add node, I'm going to put another resample node in. And this gives us some control over the number of points. So you can see we can change the distance between the white lines. So we'll make the distance a bit smaller, and let's make our grid size a bit smaller as well. And we want to hook this up the output of our sweep. And while we're at it, let's add another colour node and make our white lines white. And because we're using the exact surface once again, we're getting some intersections, so we probably want to transform that a tiny bit as well. So now we have our white lines running down the middle of the road. And once again, it's procedural, and we can change any of our input settings and it will maintain its position. Now we want to create barriers along the side of the road, and we do this in the same way. So we go back to our line input, and we want to create some more groups. This time I'm going to use the group range node. And first of all, we want to select the first point in the range. Best way to do this is turn the points on. If we start at point 1, you'll see that selects everything but the first point, and then invert it. So that way we'll always get the first point. The reason I've done it this way is we don't know how many points they're going to be. And then we're going to create another group which does almost exactly the same, but this time it selects the last point. So now if we go back to our original line and add some more points, you see it's still selecting the last point and the first point. So we'll call this one, not actually sure if this is the inside or outside edge, so first of all I'll create a group and then we'll find out. So if we do another add, so again we want to come from our surface that's been projected. I think we're actually getting points in this add as well, which is not what we want. Go to polygons, yeah, remove unused points. So we'll do the same for this one. And let's take group 1. And that looks like our inside group. The group it would be would depend on what direction the curve is going. So we'll go back up to group 1 and call it in. I think I've changed the wrong one. I want to call that. Middle. And then this one becomes in, and this one becomes out. And now we can add a new group and call this out. So now we have two more curves that run around the inside and the outside of our track. Let's switch this on so you can see in relation to the track. And it looks like I've got that wrong way around. Oh, it's not terribly important. So the next thing we want to do is make a barrier that we can copy around the edge of the track. So I'm going to create a cube. I'll just make something really simple for now. We will add another resample and another sweep. Oops, I think that's the wrong way around. Nope. So that should be our cross section. See what's wrong now. Adding two curves into there. We want our cube. There we go. And now it's a bit easier to tweak the size and scale. So here's our barriers along the side of the road. We probably want them to join up with each other or come as close as possible. We can do that by changing the length of the resample. There we go. And we would like our barriers to alternate red and white, so I'm going to go back to our resample points and I'm going to use a group range again. And this time select every one of two, which will give us, go to points, which will give us every other point, and I'll stick a colour node in before that, which will colour everything. That will make them all white, and then we'll stick another colour one in afterwards and only change this group, so we'll call this group red. And when we sweep those around the curve, they should automatically pick up the colours as they do. And we'll do exactly the same thing for the other curve. Got confused with our sweeps. There we go. And hook these up to the merge node. now we have our track with barriers along either side of the road. If we want to be a bit more clever, maybe we don't want the barriers around the outside curves, because that could be quite damaging for the car. So we need a way of knowing which curves are inside and which curves are outside. So probably the best way to do this is go back and look at our curves that we created and look at how far apart the vertices are. So you can see where there's an inside curve, they tend to cluster together, and where there's an outside curve, they tend to be further apart. This is a result of the backbones and the way they rotate around the track. So we should be able to use this. If we write a little vex node, so VOP node, so if we create an attribute VOP, what we want to do here is take the position at each point and measure the distance to the next point, which is fairly straightforward in an attribute VOP. So if we take a look in here, P is our point position. We use distance to measure the distance between that point and another point. And for the second point, we want to bring in an attribute from outside. So we want to import a point attribute. We're taking it from the same file, so we'll just use input1, which is where our curve is hooked up. The attribute is P, that's the default, and it's a vector 3. So all we need to change is the point number. So if we take the current point number, do an add constant, and add 1, and then input this into second distance, and we'll output this as a new attribute. So we do bind export and create an attribute called spacing. And now if we look at our geometry spreadsheet, that attribute has appeared, and it seems to vary between about 0.1 and 0.4. If we want to visualize that, we could add a color node and hook that up to an attribute ramp. So let's go from 0.1 to 0.4. And I need to give it our attribute, which is spacing. So now you can see you're getting different values for inside curves and outside curves. So long as we stick our attribute VOP in before the resample node, then any resampling will take it will simply take the closest value. If we were to put the resample node in first, then it would even up the distance between our points, and we wouldn't be able to use this technique anymore. So I'll do the same for both curves. And now we have an attribute called spacing, which should have copied over onto our barriers. So if we take a look here, you'll see we have a spacing float, and we should be able to use that attribute to create a new group. And there's a point group, so select points, and we will give it a value of say halfway between our two extremes, so 0.3. And then we want a blast node to remove everything in that group. See what's wrong. I've got an @ symbol instead of a greater than symbol. So now you can see it's selecting the inside corners. And we want to delete non-selected. We can play around with our value a little bit. So 2, probably a bit much there. Let's make it 0.25. Actually looks like it's doing the opposite of what we want here. Let's make that less than 0.25. There we go. Because we're doing exactly the same thing to both our curves, we can just merge them in advance. They should both have the same attribute values on them. So now you can see we have a barrier around the inside curves and not around the outside curves. Notice that I was getting a bit of a gap. There's a tearing. Yeah, here we go. So where the ends are joined, this isn't very neat. I think this is probably as a result of the ends node, because we're unrolling our shape to remove the center. There's actually a disjoint because it's no longer a continuous line, and we don't actually need to remove the center because our sweep node will just use the outside curve. So if we take a look at it now, we have a surface here, but that's being rejected when we use the sweep node anyway. So I'll just delete the ends, and now all our lines join up neatly and we don't have a gap. This one's just caused by an intersection, so we can lift it a little bit more. And now we have a completely procedural track which places all the barriers in the correct places for us as well. So if we go back to our mountain, we can play around with this, and you can see that everything updates as it should, and the same for the curve. Not sure why that's connected, it doesn't need to be. So we can move the track around and the barriers will update correctly. If we were building this as a track tool for, say, for something in Unreal, then this is extremely useful because we can make our digital asset from here down and keep our mountain and our curve separate. If we were going to do that, we probably want a null node in here just to give it a single input. So, and Unreal will let you add a curve to a Houdini digital asset, and you can also add a surface. So we could have these being created by the game designers, and then this tool would simply place the track where the curves go and correctly put lines down the middle and barriers and things. so you can see how useful this would be for quickly generating geometry that was consistent. I'm going to speed up the end of this video and play around with this a bit to get some nice renders and maybe add a few more objects to a track. I hope you've enjoyed this tutorial and found it useful, and please subscribe and come back for the next tutorial.